Hello, I am S.kumaravel, research scholar doing research in Savitha School of Engineering, Simats, Chennai. The title of the paper is Performance of Thermal Energy Storage Materials in a Single Slope Solar Steel Plant for Agricultural Usages. First, we will discuss about the basic scenario of water available in the global. Water and energy scarcity is one of the main global challenges for the future generation. The significant decrease in quality and quantity of available fresh water has harmful effects on human health. Solar distillation represents a sustainable solution to water shortages. It is a technically feasible and operational method. The technique is based on the evaporation and condensation process. The evaporation takes place due to the solar radiation. Condensation takes place in the evaporated water inside the solar still. The solar desalination process operated according to the availability of solar. Solar radiation is freely available from morning to evening every day. Solar energy is stored in any heat storage device in the daytime. The stored heat is utilized for any heat requiring system between 6 p.m. and 8 a.m. In general, I found the research gap, which is operating time and the productivity. The basic objective of this research paper is to improve the performance of solar desalination, to improve the productivity of freshwater yield by using energy storage material in a single slope solar still for the usage of agricultural purpose. Then we will discuss about the methods and materialization. Initially, data of input of sun radiation, wind velocity and ambient temperatures are observed for conducting the experiments. Then the materialization for experimental setup of single slope for solar still with the energy storage materials. Then the calibrations of instrumentation is done for experimental setup of the same, and the values are measured from the experimentation of a single slope solar still and the single slope solar still with the energy storage material. Then finally, the results were compared of the comparison of single slope solar still and single slope solar still with the energy storage material. The single slope solar steel basin is made up of a stainless steel sheet of 1 meter into 1 meter square shape. The outer side of the basin is surrounded by 20 centimeter thick thermocol insulation. The first square shaped transparent plate is placed above the basin. The level indicator is placed inside the square basin for maintaining 2 centimeter depth of brine water. The K-type thermocols are measuring the temperature of single slope solar still. The range between 50 to 220 degrees Celsius. The freshwater yield is measured by collecting jar range of 0 to 1000 ml. The depth of the brine in the basin is maintained at 2 cm by solenoid valve. The energy storage material is placed inside the solar still used to extract the heat from the radiation. The maximum solar radiation measured in the month of May in Chennai, India. The experiments were conducted on a sunny day from 6 a.m. to 8 p.m. After the experimentation, with the help of the values, the following graphs were plotted and it shows the results of the experiment. This graph shows the variation of solar intensity and the concentrating time interval. And this graph shows the evaluation of water and glass cover temperature from solar stills. And this graph shows the sunshine hours distillate output in solar still. between 6 a.m. to 6 p.m. And this graph shows the variation of displayed output for variant solar steels solar steel with the blue metal stone and solar steel pebble stone and alone solar steel. Out of this, the solar steel with the blue metal stones gives the higher distillate output. With this experimentation results, it is concluded that the high specific heat capacity and the porous structure of stones makes them a prime thermal energy storage target for maximum distillate production around the clock. The solar steel with the blue metal stones and the pebble stone produce 18% more drinkable water than the standalone solar steel. For solar cells that employs blue metal stones as a thermal energy storage material, there is a high degree of consistency among the theoretical and experimental results. Thank you.